Today we're going to take a look at composing two functions and evaluating numbers within those two functions and algebraically working with the two original functions. So first, what is a composite function? Say you have two functions f and g. Let's call f of x, x plus 1, and then g of x, 3 minus x. When we look at the composition of a function, we're looking at f composed with g. That little circle in the middle, this is not the word fog. This is f, the function f, composed with the function g. So this composed with this function. When we do that, notationally, we write f parentheses and then inside g of x. It's important to note that when you find compositions, you have to use this notation. You write this first, then this guy. Now, f of g of x, we're going to take g of x and substitute it in. So 3 minus x. Next, f of some number, whether it's a function or a value, this notation means take this 3 minus x and substitute it in for that x value. So that gives us whatever the x value is plus 1. Remember, now we're writing this parentheses represents this x here. So we're going to substitute in the 3 minus x. That gives us then 3 minus x plus 1, which is just 4 minus x. This, folks, is f composed with g of x, and you're done. Here are two others. You can, when you have this composition of functions, say, I want to compose those functions and I want to evaluate the composition at 2. We can do this two different ways. First, we can write f of g of 2. Then, inside here, we want to put what g of 2 is. G of 2 is 2 evaluated inside the function g. So we put 2 minus 1. So that's f of 1. Now we're back to that old notation, f of some value. That means take this 1 and substitute it into this original function. So we get 1 squared, which is just 1. That is f composed of g of 2. Another way that we could do this is to actually take that g of 2 and do it separately and put it inside, or we could find f composed of g and then evaluate it at 2, like this. So another option, f composed of g of 2, we're going to first find f composed of g of x, which is f of g of x. G of x is x minus 1. Let's substitute that in. And then f of x of 1, x minus 1 says put the x minus 1 inside here for the variable. So x minus 1 squared. That gives us x squared minus 2x plus 1. Now, when we find f composed of g of 2, we're substituting in the 2. 2 squared minus 2 times 2 plus 1. Well, this is 4 and this is 4. They add to 0, so you just get 1. And, folks, same exact answer. So either way works. You try this one, please. Hit pause and then come back. Okay, we're going to do this embedded within it, f of g of negative 1. That's taking this and taking that next step right away. And when you do that, it's an equal sign, equals f of, what's g of negative 1? Now, you may want to come over here and do that so you don't make any mistakes with more complicated functions. Then you take that negative 2 and put it in here. Now, what's f of negative 2? It's negative 2 squared, which is 4. And you're done. That's your final answer. We can find a formula again. We did this on the first slides. If you think you're ready to do it on your own, go ahead and do that. Pause the video and come back and check. F composed of g of x is f of g of x. Let's go ahead and substitute in for that g of x Now we're going to take the x minus 1 and substitute it into the original function here where the x is, and that gives us x minus 1 quantity squared, x squared minus 2x plus 1. And that is f of g of x. If your notation or your equation solving is a little sloppy, start working on that. You can keep writing this at each level, or you can skip the first couple as long as you have it here. Then just rewrite it at the end so that we have our final answer. We can do this in reverse as well. G composed of f of x is really g of f of x, which is g of, put the f of x inside, and then now g of x squared, that's saying take x squared and put it in for the variable. So that is whatever the variable is minus 1, so we're going to substitute in the x squared. So we just get x squared minus 1. And this is g composed of f of x.